Hello everyone, myself Prathamesh Zagre and we are going to present on digital simulation of test-based analysis. Our group members are me, Prathamesh Zagre, Rohit Takvere, Avantika Bhosle and Deepali Kale under the guidance of G. Vijay Kumar sir.
State space analysis. State space analysis is an excellent method for the design and analysis of the control system. The conventional and old method for the design and analysis of control system is the transfer function method. The transfer function method for design and analysis had many drawbacks. So, state space analysis and simulation often go hand in hand. Now we will see the some definitions of the state space analysis. First, system state. It means that the minimum information needed in order to completely determine the output of the system from a given moment, provided the input is known from the moment. Second, system variables. In variables that responds to an input or initial condition in a system. Third, state variables. The smallest set of linearly independent system variables such that the values of the set members at time t0 along with known forcing function completely determine the value of all system variables for all t is greater than or equals to t0. Fourth, state vector. Vector whose elements are the state variables. Fifth, state space. N-dimensional space whose axis represent the state variables. Sixth, state equations. A set of n numbers simultaneously first order differential equation with n variables where n variables to be solved are the state variables. Last one, state space representation. A state space representation of an LTI system has the general for the X.
Hello everyone, myself Rohit Takpere, roll number 74. I am going to explain the block diagram of the circuit. The input voltage is connected to V matrix. The V matrix output is connected to a summing point, and the summing point output is connected to the integrator to integrate the output. The integrator output is also feedback to a summing point and also sent to a C matrix. The C matrix output is connected to a scope to see a output waveform. And the second circuit, the reference point is set in 50. The reference point output is connected to a summing point. The summing point output is connected to a integrator to integrate the output, and the integrated output is connected to a gain. The gain output is connected to a summing point. The summing point output is connected to B matrix, and also the B matrix output is connected to a summing point. The summing point output is sent to the integrator. The integrator output is feedback to a to summing point. The C matrix is connected to a integrator. The integrator output sent to mux and also the first summing point. The mux is used to see the reference point and C matrix input, and the mux output is connected to a scope to see output waveform.
Now I am going to explain components. We had used here input supply of 12 volt. Then we had it connected to the B matrix. We had used here three matrix: C matrix, A matrix and B matrix. At middle we had put a constant of 1 by S. It is given by the supply. It connected to the 3 matrix and afterwards it is gone to the scope. After this we will see the graph and waveform. At first we are going to see open loop graph waveform. In that we had used 3 matrix ABCD and input supply of 12 to find space. So this is an waveform of open loop. It rises upside.
Advantages of state space analysis. First, it is applicable to multiple input and multiple output system. Second, it is applicable to system with non-zero initial condition. Third, it is applicable to both linear time invariant and non-linear time varying system. Fourth, all the internal state can be determined. Fifth, it is more accurate than transfer function. Sixth, it gives the information about controllability and observability. State space representation. In order to select the state variables, we must follow the rules given here. A minimum number of state variables must be selected. B. They must be linearly independent. The minimum number of state variables require equal the order of differential equation